Hello and welcome again. In this video I want to talk about microscope eyepieces. Eyepieces are those parts of the microscope where you look through. There is an objective here, and I've made several other videos on objectives, but today I want to talk about this part here, the eyepiece. So stay tuned. Okay, so well, first of all, there are different types of microscope eyepieces, but all of them have one thing in common, namely they magnify an image that was projected by the objective. So if you have a microscope objective here and you're looking at a specimen, then this objective will project an image into the tube of the microscope. You cannot really see this image directly, but if you were able to place a sheet of paper into the tube, into the microscope, then you would be able to actually see the image projected on this screen, on this sheet of paper. Obviously we don't have a screen inside the tube of the microscope, but there is the eyepiece, and this eyepiece will now magnify this image that was projected. And there are now several different types of parameters or characteristics that describe the eyepieces, and in this video I would like to talk about these. The first thing is I've categorized my eyepieces into three groups here. On the left you see eyepieces for compound microscopes, so that's basically these ones that you have here. In the middle, these are eyepieces for stereo microscopes, and they are not compatible with the eyepieces of the compound microscopes because the diameter is different, so you cannot make them fit. And on the right side, well, these are eyepieces for telescopes, so I will not be talking about them very much at all because they are again different. They too magnify an image that was created by the objective, but it really doesn't work. You cannot really fit them into a microscope. Now I'm saying this because there are some telescope eyepieces rather that have a very similar diameter. Okay, it's a very similar. It almost looks the same, but it still will not fit because there's a small difference. Okay, so as a general rule, exchanging of eyepieces between different types of microscopes and with telescopes, that's actually not going to work. Okay, so now let's have a look at some of the more specific characteristics. Well, the first important thing is that the magnification of the eyepiece. This one is in almost all cases printed on the eyepiece. Most microscope eyepieces have a 10 times or a 10x magnification, and the total magnification therefore for the microscope you get by multiplying the magnification of the objective. In this case it's also a 10 times multiplied by 10, so in this case I would have 100 times magnification. There are some eyepieces that have 20 times, 25 times even, but those, I would say that those eyepieces are not really commonly used. I know that they come along with some microscope sets so that you can increase the magnification yet further. But I would say that in research area and also in the educational area, they're not really very common because even though you can make the object appear larger by adding a stronger eyepiece, you do not really gain anything in resolution. This means it's just going to be larger but also more blurry, so you do not see any more fine details. However, I do admit there might be some specific cases where it's simply more convenient to get a higher magnification, even if it's a little bit more blurry, simply because you see it larger. Okay, but if I were to buy myself a second set of eyepieces, then I would probably not buy myself eyepieces with a higher magnification, but rather one with a lower magnification, like for example 5 times. The reason is because then I can also place larger objects under the microscope and can still look at the whole object at a lower magnification. At least from my use, I would have more of a use with a lower magnification eyepiece than a higher one, but that's also a question of personal preference. Okay, so that's basically one thing, magnification. The second thing is the so-called the field number of the microscope, and this one is not always printed on the microscope. There are so-called wide field eyepieces. Sometimes it's indicated with WF, and then there are also some regular eyepieces, so to say. What is the difference? Basically, eyepieces with a larger field number at a given magnification, you can see simply more. Okay, so basically the circle that you look through, at when you look through the eyepiece is larger. That means you see more of the specimen. I mean, it is like this, that the magnification is still the same, but as you simply still see, it's less of like looking through a tunnel, but more like, yeah, you get a better visual subjective impression because you simply see more. This has the advantage that it allows you to really navigate better. It gives you a better orientation because it's not like looking through a small keyhole, but actually you get a more a fuller view, a fuller vision, and therefore it's also subjectively more pleasing, and also I would say probably for long-term microscope use also better, okay, because it's less yeah, you don't need to concentrate less, and you simply see more, and that's simply nicer. Okay, however, it is like this, that those wide field eyepieces of course are more expensive, and if the objective itself is not of high quality, then because you simply see more, it could be that the sides are a little bit more blurry than in a narrow field eyepiece, because the further you go away from the center, the blurrier the image becomes. These are so-called lens errors and aberrations. However, even if that were the case, I would, if I had the money, still would buy wide field eyepieces, because your center, if the parts that you want to look at, you're going to move into the center anyway, so it doesn't really matter if it's a little bit blurry on this side. Okay, I'm just saying this. Even this disadvantage of being blurry is not a really big, in my view, not a very big disadvantage. Okay, so that is so I talked about magnification, talked about the field of view, and here there's a small comparison image now of basically the same specimen at the same magnification. Yeah, and I used a mobile phone camera in this case to take the picture, and you can see that in the one with a large field of view, you simply see more of the specimen. Okay, so what's another thing? Okay, and another thing is the following. I'm going to take this out. Is the so-called the eye relief. These are pretty good and expensive eyepieces, obviously. If you look at it carefully, you're going to see that there's an interesting thing that you can extend here, and if you're able to pull this out, okay. But what you're pulling out here is really not. There are no lenses here. It's simply an empty, a hollow barrel. And what this does is the following. These are eyepieces with a so-called a long eye relief. Now, what is the eye relief? The eye relief is the distance that you have to have between your eye and the eyepiece. So for a long eye relief eyepiece, you have to be further away from the eyepiece to see an image. And for those eyepieces that have a short eye relief, you're almost sticking your eyes indirectly into the lens, so the distance has to be very small. Now these, however, eyepieces with a long eye relief are really good if you wear eyeglasses like I am doing right now, okay? Because then I simply put it in like this, and then my eyeglasses are able to now set the distance between the eyepiece and my eye. So I have already the correct eye relief adjusted because my eyeglasses are further away from my eyes, and they kind of keep the distance, okay? And if I basically want to look at the image without my glasses, then I have to kind of make sure that it's kind of, there's got to be some kind of a distance. It's difficult to find, and in order for me to help me find the correct eye distance, you can extend the front part, and then I can still rest the front part on my eyes, and yeah, and have the correct eye relief distance. So if you wear glasses, get yourself eyepieces with a large eye relief, because then you can look at the specimen without having to take off your glasses, okay? So that is another thing. I mean, this one, for example, you can see that it looks different, but actually it's the same principle. You can also extend the front part. By the way, there is another nice side effect by having this is long eye relief eyepieces, is because your eyelashes don't touch the lens, and then there is less yeah, oil and dirt on the surface of the lens, okay? So long eye relief eyepieces do have an advantage, but yeah, that's kind of the thing. Okay, so what else do I want to say? There are also eyepieces, so-called special purpose eyepieces. Actually, you shouldn't call them eyepieces. I like to call them photo projection ocular, or some people call it photo eyepieces. And what they are is, and not every microscope has this, but some manufacturers, especially if your microscope is not manufactured anymore, like for example these here, they have special purpose eyepieces. And I'm just going to take this off here, the top part, to show you what they are. And what you can see is you can see that there is a photo projection eyepiece, photo projection ocular in there, which is responsible for taking the image of the objective and projecting it into the camera. Okay, so yeah, theoretically you could also use a normal eyepiece for doing the photo projection. Some people actually do. However, the image quality is a little bit lower because those photo projection oculars, they have they're correcting lens errors of the objective and a whole bunch of fancy other things, which they don't do. But in principle, you could theoretically exchange this and it would also work. So this is basically all I wanted to basically clarify to you today, and maybe as a last comment, if your microscope does not allow you to exchange these eyepieces, then just be aware that some microscopes have a small tiny screw here that holds it in place. So especially educational microscopes, so you cannot remove the eyepiece because it's held in place with a screw. These are so-called student-proof microscopes. And that is another thing that I just before I keep on remembering things. It's like this, that sometimes what you can see is there is a so-called you can also include into the eyepiece itself either a grid, a micrometer, or an arrow. And if you do that, then this image of the arrow or the grid will be superimposed over the image of that you see. And this sometimes can also be an advantage if your microscope comes with an arrow. This is usually a little line that kind of points inwards, and if you do not want to have this arrow visible, then you can always remove it by going in the back and unscrewing the eyepiece and taking it out. Okay, so that is simply a last recommendation. So that is basically all I wanted to say today. I hope it was informative. If you liked the video, please like and subscribe. I wish you all the best, and as always, happy microbe hunting. Bye bye.